Here we have question 11 on the January 2017 Algebra 2 Common Core Regents, and this is a quadratic equations question. And the question reads, the solution to the equation 18x squared minus 24x plus 87 equals 0 is what? And we have four answer choices. Now, you should note pretty quickly that all of the answer choices feature a radical, rad 158, which is not going to be simplifiable, otherwise we would have simplified it. And they also feature an I. What that should tell you right away is that the only way to solve this quadratic is going to be by doing the quadratic formula. And we have an A of 18, a B of negative 24, and a C of 87. And there's nothing here that we can factor out. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's fill this in. Negative 24 is just positive 24, plus or minus b squared, that's negative 24 all squared, minus 4 times 18 times 87, all over 2 times 18. So all we did here is fill in the A, fill in the B. Oh, there was one more A down here. And fill in the C, which is here. All right, so now it's just a matter of getting the numbers reduced. So we have 24 plus or minus negative 24 squared. It's 576. There's 4 times 18 times 87. We'll have to do that on the calculator. And 2 times 18 is 36. And again, you can do this whole thing on the calculator, but I'm going to recommend just doing the inside of the square root first. So again, we could verify that 24 squared is indeed 576. Now, you don't want to put this in because the calculator will give you negative 576. The reason for that is it will do the squared first and then negate it. What you really mean to put is this. But we should know that a negative squared is just a positive, so we can just put in 24 squared there. And then we're going to subtract 4 times 18 times 87. And that'll get us the inside of the square root. So we have x is 24 plus or minus the square root of negative 5,688 over 36. Now, this is a very unwieldy number, so what we want to do here is see if we can take out some perfect squares. So try to divide it by 4. That works. Why don't we try some higher numbers, though? Especially because we know what's left under the square root in all four answer choices is 158. So we could try by 9. That also works, which would seem to indicate to me that we should be able to divide it by 36, the perfect square of 6, because both 4 and 9 can be divided out. And sure enough, that gets us our 158. So what that means is we can separate the 5688 into rad 36, rad negative 1, which is our I, and rad 158, all over 36. Now we can simplify this further. Radical 36 is 6, radical negative 1 is I, and then rad 158. And then that's all divided by 36. Now you'll note our answers here have a separated fraction for just the integers. So I'm going to separate this out into 24 over 36 plus or minus 6i rad 158 over 36. 24 over 36 we could simplify to 2/3. You could do that in the calculator. You could do it by hand by dividing top and bottom both by 12. Plus or minus, now the 6 and the 36 reduce to a 6 in the denominator. So 1/6 I square root of 158. And that answer is 4. The trappy answers here are going to leave you with a 6 in the numerator instead of the denominator. Well, we have 6 over 36, so that's definitely going to be in the denominator. Or they'll have negative 2/3. And it's not negative 2/3 because b itself is already negative 24. So when we put that in for negative b, it's negative 24, which is positive 24. So be very careful with your negatives and be very careful with your factoring here and be very careful with your fraction division. It's a complicated question, not necessarily because of the concept. The concept of substituting in numbers to the quadratic formula is itself pretty simple, but there's a lot of opportunity here to make a silly kind of error where we divide wrong or forget a negative or something like that. So as always with these long algebraic questions and these quadratic formula type questions, be particularly conscientious about following up with your negatives and following up with your fractions.